Hello guys, good evening. Hope you guys are doing great. So this is a video to help those that have problems designing a 4-bit ALU using a simulator. Okay, now the first thing we are going to do in the video is actually going to the site that has the simulator and actually downloading the simulator. Now this is the link. Okay, when you enter the link, it's in the description below if you're wondering how you can get the link. So when you enter, you should come to a page. Sorry about that. You copy and you paste it here. Okay, you see I've visited it before, so you enter it. So it opens this page. Okay, now in this page, what you do is you go to software. In software, now you will need actually to download. They give you some guidelines that you will need to have the Java runtime environment. Okay, it's easy. Now you need Google Chrome, of course, and then now you can download for Linux or you can download for Windows. I'm using Windows, so I'm going to download for Windows. Okay, when you hit download button, it asks you where you're going to save it. I'm going to save it on desktop. Okay, so as you can see, it's 12.8 megabytes. That should not take too long. Okay, so what we're going to be doing is we're going to be downloading it. After downloading it, we have to open it and explain a bit some of the issues inside. So I'm just going to go ahead and open another page. The page that actually has the design of what we are supposed to construct. This is it. So basically, this is what we're supposed to construct, to design, and this is an arithmetic unit, a 4-bit arithmetic unit that is made up of 1-bit arithmetic and logic units. Okay, it's made up of 1 bit, in which you can see the control signals here, S1 and S0. They are the ones who decide which one of this is executed. Okay, they are the ones who decide if it's an AND. They are the ones who decide if this F0, which is the output, is an AND, is a result of an AND, the result of a OR, a result of a XOR, or the result of this adder. Okay, they are the ones who control it. Now here you can see F0, F1, F2, F3. So think of it like each of these 1-bit ALUs, okay, have this, okay, have this image I'm carrying. Okay, they have each of these inside them, okay, incorporated inside them. You see it. So now based on the signal, the signal, which is S1 and S0, they are a pair actually. Okay, based on the signal, you will have what is going to happen. Is it the result, this F0, F1, F2, are they going to be as a result of an AND? The AND of A0 and B0, are they going to be a result of as a result of A0 or B0? Are they going to be the result of A0 XOR B0, or are they just going to be the result of A0 plus B0 plus C0? Now it's based on the S1 and S0. Now you can see the design issues here. They say the security functionality of a 1-bit ALU is shown here. Depending upon the control signal S1 and S0, the secret operates as follows. You see that when S1 is 0 and S0 is 0, the output is A and B. What this means in this case is that when S1 and S0 are both 0, what happens is that I told you that this particular stuff here is in each of these. Okay, so when S1 and S0 are 0, 0, this says that since we start here, then we go here, then we go here, and we finally finish here. Since everything starts here, what happens is that when S1 is 0 and S0 is 0, what happens is you have now the signal, the output is supposed to be as a result of A and B, meaning that this is what is going to give the result F0. Okay, this one, and this one are ignored. These three are ignored. Okay, this is going to be the result of this is going to be the result, the output here, when S1 is equals to 0 and S0 is equals to 0. I hope you guys are following. Okay, now instead, if S1 was 0 and S0 was 1, the output is A or B. Okay, the output is A or B. This means that what? If you're here or here or here or here, anywhere, okay, since they all have this, okay. The thing is that if S1 is 0 and S0 is 1, the result will be as a result of A or B, meaning that this, the OR gate, comes into play. You see, so this result, which is this result, or this or this or this, is actually as a result of the OR gate. So all the others are ignored, okay. All the others are ignored, and the actual output of the ALU is the result of ORing A and B, okay. That's just it. So you have S1 equals 1, S0 equals 0, XOR. So meaning that this one will be the one that will give the result, and all the others will be ignored, okay. And it's likewise for 1 and 1, okay. You have that this one is the one that is going to give the result, okay, and this one is not going, these other ones are not going to be carried out. Now, one important thing you should note is that this arrow is actually the C out, okay. Now you have C out there. You realize that there is a carryover because this is a carryover, okay. These are carried over bits. The carried over bits can be 0 or 1, okay. It can be 0 or 1. Now realize that in the arithmetic logic unit, you have an arithmetic unit which basically does the adding, and you have the logic unit which basically does the AND, the OR, and the XOR, okay. Meaning that what? Meaning that for you to have a carryover bit of 1, okay, you will need to be in the add, okay. You will need to be in the arithmetic unit, and the only time you're in the arithmetic unit is when S1 is equals 1 and S0 is equals 1. That is when you might have a carryover of 1, okay. You might, because based on the values of A0, B0, okay, you might not actually have a carryover of 1. You might still have a carryover of 0, but it is possible that you have a carryover of 1 because you are actually in the arithmetic unit, because S1 is equals 1 and S0 is equals 1 makes the output to be A at B, which is this adder in which you can have this C out, okay. But in the others, the C out is always 0, okay. So I'm sure the thing should have finished downloading. Okay, this is it. So basically they said you need to have, okay, this is it. This is the software, okay. This is the software, and basically you can look at it. You have a set of tools up here. You have the open. When you want to open, maybe you see some of the stuff I've done already, okay. You have the save, you have the save as component, you have the load existing component. Components are just like you've created a piece of circuitry and you actually want to add it to another circuit, so you just add it as a component, okay. You can load existing component here if you want to export and print. Here you generate a net list. Here you simulate, here you do a case analysis, okay. You just analyze what you've done. Here you have this, actually what you press when you want to test if what you built is, what you designed is working, okay. You run the simulator, and you have other bunch of tools that you might not use for a start, but I encourage you to go inside them and actually try them. So you have basic stuff here, okay. Now these are the tools you will need, okay. Here you have the selection tool, the palette, okay, that has everything. Now you have the selection tools, okay. Presently it's on selection, meaning I can select anything, okay. As you can see, this is connection. So say you have two things, like you have an adder and you have a display, okay. The connection helps you in connecting these pins to these pins, okay. That's the connection, okay. So I have other bunch of tools here that we're not going to use, but I encourage you to go and try, okay, to go and try it again and again and again, okay. Now the next guy is circuits and labels. So these are circuits, okay. you just click and click. Okay, this is click and click. You just click and you click here, you click here, you click here, you click here. Okay, now this is a part for the gates. You have many, you have the or, the and many others. Okay, as you can see, or and this and that. Okay, I encourage you to look at them. Okay, now we have the input and the output. We have the bit display that we're going to be using, and bit switch that we're also going to be using. Okay, we're not going to use clock pulse or digital display. So without wasting most of your time, what we're going to need is this guy. Okay, so let's start with what we have to do. So basically, as I explained, okay, these are the design issues here. Okay, now based on what was actually done, this is actually what we have to design. Okay, this is what we have to design. It's a 4-bit ALU that's made up of 1-bit ALUs. Okay, 4 1-bit ALUs. Okay, now you realize that all what is on top, okay, of each ALU are the inputs. Okay, and what is down are the outputs. Okay, now realize that the inputs are entered in an anti-clockwise manner. Okay, meaning that this is the first input. A0 is the first input, B0 is the second input, C0 is the third input, S0 and S1 are the next inputs. Okay, you're seeing that they're entering like this in towards the left. Okay, and it's the same thing for the outputs. The outputs are they come out going towards the left. So the first one here is the actual output from the operation of this ALU, and then you have C out, which is the carryover bit, which is just transferred. Okay, it is carried over to the next ALU for processing. Okay, and just like that, each carried over bit is carried to the next ALU for processing, and now finally at the last ALU it is somehow outputted. Okay, so let's start designing. So we have, it's very simple. Okay, all we need to do is put our ALUs, our 1-bit ALUs. Okay, you click and click basically. Okay, click and click. Okay, these are them. Okay, now what we do is we know that we have S1 S0, S1 S0, S1 S0, they're almost everywhere. So instead of putting them everywhere, I'm just going to put them on the top. Okay, at the top, sorry. Okay, you see. So now the next thing I want you to notice is that I'm going to put bit displays down here, and that is because, as you can see, I actually want to be able to see this output. Okay, so I put 2 here because of the C out. Okay, I actually want to see what my carried over bit from the operation on the last ALU is. Okay, so I just click and then add. I click, I add, I click and I add. It's actually fun, guys. It's fun, really fun. So now let me try connecting a bit. So I told you that the first pin here is for the output. Okay, they are the outputs. The first output, let me change that line. This is where you change how the line is, how the connection is. Okay, I'm going to change mine so it becomes a line. Okay, so now I connect this, which is my C out, to this. Okay, now I connect my output here to this. I connect my output here. Notice it's the first pin, bottom right, okay, of each ALU that is connected to the bit display. Okay, so now the next thing you want to do is realize that on the picture you see that every carried over bit is at the third position, anti-clockwise. You see a bit of the inputs, so you have C out here at the third position on every of the ALUs. Okay, except for the first one, which has a default C0 value. So what we are going to do here is realize that this is the second one. Okay, so it's my C out, so I'll take it and count 1 2 3. So it's supposed to be here. Okay, I put it here, I click. Same thing here, I take the second one under, I drag it, I count 1 2 3, I drop. Okay, same thing here, I take it, I count 1 2 3, I drop. Okay, you see that we have finished the connection for the C, all the C outs, and the connection for the outputs, okay, to bit displays. Okay, now the last thing we're going, well, one of the last things is that we're going to actually connect this because this is S1 and this is my S0. Okay, since they are found everywhere, I put them at the top so that I can actually have lines connections going all through. So the first one I put is S0. I'll put the S0, so I count 1, 2, 3. I know that this 3 is for C0, so I come here at the 4th position and put my S0. Okay, here I put it 1, 2, 3, 4. I put it here. Sorry, I put it here. Okay, and then I count again 1, 2, 3, 4. I put it here, and I count again 1, 2, 3, 4. I put it here. I'm done with S0. Now I go to S1. I know S1 comes immediately after S0, so I have S1 here to the first ALU, S1 here to the second ALU, S1 here to the third ALU, and S1 here to the fourth ALU. Okay, so basically we have we have connected S1, S0, okay, all through, and we have C out and P0. Okay, so all we need to do now is C0, B0, A0, B1, A1, B2, A2, and B3, A3. So we are going to use bit switches again to represent the bit. So this is supposed to be A3, this is B3, okay, this is A2, B2, this is A1, B1, this is A0, this is B0, and this is C0. Now you might be wondering what C0 is. C0 is a carried over bit from the most recent instruction that was processed by the CPU. Okay, so now I'll connect them. I know that this guy is the first pin, so my A's are on the first pin, top right, okay, top right of each ALU, okay, while my B's are immediately after the A's. Don't forget it is anti-clockwise, okay, anti-clockwise from top right to top left. Okay, so I connect, sorry, I connect, okay, I connect, and I connect. Now at this point it is complete. Okay, we have designed it completely, and you can see that it actually resembles this. Okay, I have S1, S0, okay, S1, S0, as you can see, S1, S0. I have C0, which is this, C0. I have B0, which is this, and I have A0, which is this. Here I have S1, S0, okay, S1, S0. I have this C, which is the output, which is the carried over bit from the first ALU. This is it, the carried over bit from the first ALU, okay, and then I have B1, B1, and then I have A1, A1, okay, just like that till the end. Okay, so you see that now at least what we have here resembles what is down here. Okay, so now realize that, remember what I told you, that from the design, okay, when S1 is 0 and S0 is 0, the output is A and B. What does that mean? Since I have a 0 here and I have a 0 here, it means I'm in the case A and B. Okay, I'm in the particular case A and B. Okay, meaning that this is true only when A is 1 and B is 1. Okay, now for the carried over bit, that is C out, okay, for C out it's always going to be 0. Why? Because we are in the logical unit here, we are not in the arithmetic unit, and it's a logical operation, and logical operation don't have carry over bit of 1, okay, only 0. So let's try this. Okay, let's have a use case. Let's suppose this is actually 1 and 1. Okay, to change the bit of this bit switch, you just double click. Okay, when I double click, it becomes 1. When I double click, it becomes 0. Okay, so let's suppose I have 1 here, and I have 1 0 here, and I have 0 1 here, and I actually have 0 0 here. What this is going to produce is, when I hit the run button, is that the result here, I'm going to have a 1 here. Okay, I'm going to have a 1. When I have a 1, the carried over bit here, as I told you, will be 0, because we're in the logical unit. Okay, because S1 is 0 and S0 is 0 means A and B. Since it's A and B, we're in the logical unit, and the logical unit, there cannot be a carry over bit of 1. Okay, so I have this 0 here. Okay, so here I have 1 and 0, which is going to give me 0. Okay, I have 0 and 1, which is going to give me 0. Okay, the carried over bits again are always 0. Okay, and then I have 0 and 0, which will still give me 0, and the carried over bit, this one, will give me 0. So I'm supposed to have an answer 1 0 0 0 0 when I hit the run button, which is actually what I get. Okay, yeah, you notice this has changed to 1. Okay, now suppose, just to show you that the carried over bit is void in the logical unit, suppose this guy was 1. Okay, when I hit the run button, nothing is going to change. Okay, nothing changes, because this one has nothing to do in the logical unit. Okay, it's a carried over bit, it's just there for addition. Okay, for arithmetic operations. Okay, so now suppose this was instead, now we're in the case where S1 is equals 0 and S0 is equals 1. The output is A or B, and now realize that these outputs that they say outputs are actually the outputs of each of this 1 bit ALU. Okay, and henceforth is the output of the total 4 bit ALU. Okay, so basically, now that I have an OR, okay, I'm expecting again the carry over bits are still going to be zeros. Okay, because we are still in the logical unit, where we are actually in, now we're in A or B. Okay, which is true whenever A or B are true, are 1. Okay, so meaning that, and again, C out is always going to be 0. Okay, because we are in the logic unit. Okay, so now I expect my result to be, this is 1 or 1, which is 1, which is going to give me 1. I have 1 0, 1 or 0, which is going to give me 1. I have a 0 or 1, which is still going to give me 1, and I have a 0 or 0, which is going to give me 0, and the carry over bit is going to be 0. So my answer I expect after hitting the run button is 1 1 1 0 0. Okay, which is actually what I get, 1 1 1 0 0. Okay, basically when you are in the logic unit, okay, that's when you have a gate like an OR gate or an AND gate or anything of that sort, the carry over bit is 0. Okay, it's always 0. Okay, now the next one is the XOR. Okay, the next one is the XOR, because they said when S1 is 1 and S0 is 0, the output is A XOR B. Now A XOR B means that A XOR B is true whenever A or B are 1 but not both. Okay, in fact, to make it even simpler, A and B must not have the same value. Okay, they must not have the same value for the operation to be true. Okay, meaning that if A is 1 and B is 1, okay, this is false in the case of A XOR B. Okay, if A is 0 and B is 1, this is true. If A is 1 and B is 0, this is still true. But if A is 0 and B is 0, then this is still false. Okay, the only time it is true is when they are of different size, and this is the case because we have just 2 of them. Okay, so basically I expect this to be false. Again, the carry over bit is 0, I expect this to be 1. So here it's 0. I expect a 0 here. I expect a 1 here. I expect a 1 here. And I expect a 0, 0. Okay, when I hit the run, you see that that's what I get. I get 0, I get 1, I get 1, and I get 0, 0. Okay, so basically that's it. Now, the last design issue was that S1, when S1 is equals 1 and S0 is equals 1, the output is A add B. Now, A add B, now we are no longer in the logic unit, we are in the arithmetic unit now. And since we are in the arithmetic unit, this carry over bit will play a large role. Okay, as you can see here, when we are in the arithmetic unit, we use an adder. Okay, now this adder adds A to B and to C. Okay, it adds A, B, and C, not just A and B. Okay, so now we have to consider C0, and in the case of the adder, you actually have a carried over bit. Okay, that can be 1. Okay, you realize that in the logic unit it can only be 0, but in this case it might be 1 based on the carry over, based on the addition of this tree. Okay, and never forget we are in base 2. Okay, we're in base 2. So let's go back to the program. So now what we expect here is, since we're in the case 1 1, which is addition, we'll have 1 plus 1 plus 1, which is 3, right? But we're in base 2, so 3 in base 2, basically we will have a 0, a 1, and we will have a carry over bit of 1. Okay, 3 in base 2 is 1, remainder 1. Okay, so we have a 1 and a carried over bit of 1, meaning that here now we have 0 plus 1 plus 1. The one that came from the carry bit of the first operation in the ALU, in the first ALU. Okay, we have a 1 plus this 1 plus this 0. Okay, which gives me 2, but we're in base 2, so 2 in base 2 is 0, and we have a carry over bit of 1. Okay, 1 again. Okay, so now we have a 1 here plus a 0 plus a 1. Okay, that's still 2. Okay, and since we were in base 2, the result here will be a 0 again, and we'll have a carry over bit of 1. Okay, now you will have a 1 plus a 0 plus a 0, which is going to give me a 1. Okay, and we'll have a carry over bit of 0 this time. So I expect a 1, okay, a 0, a 0, a 0, and a 1 when I add it, and that is exactly what I get. Okay, a 1, a 0, a 0, a 0, and a 1. Now, for those of you that might be confused about the addition, this is actually what happens. Suppose you have 1001 that you have to add to say 1010. Okay, 11. Okay, now the result here is actually going to be, now when you add 1 and 1 in base 2, what you actually get is 2. Okay, no, sorry, when you add 1 and 1 you get 2. Okay, but since we're in the binary system here, okay, 2 in base 2 is 0, and we have a 1. Okay, 0 1. Okay, I don't know if you guys are following, but it's 0 1. Okay, so we actually have a 0 here. Okay, and then we have a 1 over here. We have a 1. Okay, the 1 from this operation here. Okay, so now we have a 1 plus a 0 plus a 1. Okay, which still gives me 2. Okay, but 2 in base 2 is again 0. Okay, and I have a carry again of 1. Okay, I have a carry of 1. So now when I add now this 1 to this 0 and to this other 0, I now get a 1. Okay, I get a 1. Okay, and then now finally I have a 1 plus a 1, which gives me a 2. But since we're in the binary system, this is 0. And then now you realize that I have a a carryover bit. I have a bit that remains, okay, 1. Okay, this is an overflow. Okay, it's an overflow, and what happens is that this bit now is carried. If there is a next operation that is supposed to happen, okay, next arithmetic operation, say 1101 and say 0011, okay, this carried over bit is going to be part of the game. Okay, it's going to be part of the game. It's going to be here. Okay, and so when you'll be adding 1 and 1, you'll be adding with this 1. Okay, so basically that's just it. So we have this. So generally that's it for the simulator. I encourage you to actually go and try to play around with these things. It's actually quite funny, and you have a lot of fun time. So thank you for watching. If there's any error, anything you find not well explained, or anything that is disturbing, please feel free to comment and let me know what you're thinking. Okay, let me know what you're thinking. In the making of the video, I might have done some 2 or 3 errors or said things that are not supposed to be said. Okay, you can just let me know in the comments, and that will greatly make me improve. Okay, so I hope this helps. Goodbye and see you next time.